Hey, how's it going? So today we're going to quickly go over the LeetCode 285 question in order successor in BST. So given a binary search tree and a node in it, find the in-order successor of the node in the BST. The successor of a node P is the node with the smallest key greater than the P value. So this tree, the in-order successor of 1 is 2. So we output node 2. In this example, we want to find the in-order successor of 6. It's none because there's no node that is greater than 6. So we'll return none. So I think the brute force is that you can just write the in-order traversal and print out the in-order traversal list, and then you just to find what is next to the value you want to find. But that time complexity will be O n, and space complexity is also O n because you want to print out the whole list, right? So there is something that is quicker. So I wrote my code here. So basically, it is like, let's say, if you want to find a node successor, the node is either on the right subtree or it's parent node, right? So for example, 3's successor is 4, right? It's if 3 has a right subtree, then it will be on the right subtree, because we know in binary search tree, the right subtree is always all the values are greater, right? So basically, if a node, so for example 5 has a right subtree, then we know the successor is somewhere in the right subtree, right? So that's why this is here. First of all, I checked the corner case where there's no tree at all, return none. And this part is quite easy. It's just saying that if the node we are trying to find successor to has a right subtree, then we know that we have to find the successor in this right subtree, right? So that's why I say if it has a right subtree, then I go to the right subtree and I have to find the smallest one in the right subtree. So that's why, well, p.left, I traverse to the left until I reach the right subtree's leftmost node, right? So that's fairly easy. That's when the p has a right subtree. What if the p doesn't have a right subtree, right? So for example, 1 in this here, it doesn't have a right subtree. What is successor is its parent node, right? So 2's successor, it doesn't have a right subtree. It's a parent node, right? So 4 doesn't have a right subtree, so it's parent node, but it's parent node because its parent is smaller than itself. So basically, if a node doesn't have a right subtree, then it has to find its parents and bubble up and find its parent until the parent's value is greater than itself. So that's why 4's successor is 5. Its parent is smaller, its parent is larger than 4. So that's why 5 is the successor. So, however, in our tree node, we don't have access to the parent, right? So that's a problem. And there is actually a LeetCode question 510 called in order successor in BST 2. So that's when you have access to parent. But yeah, that's a different question. You can try that. But this question, we don't have access to parent. So how do we do that, right? So it's a little bit complicated, but basically, our algorithm is just to traverse the tree using a stack. So this is iterative tree traversal, right? So let me comment out this. So basically, all this code is the iterative in-order traversal. So this is just a template you can remember. If you don't understand this, then go back to the in-order traversal of in-order traversal question on LeetCode. Yeah, basically this is a template that maybe you can just remember, right? So I just like copy paste the template here, and all I do here differently is this 3 lines. It says if, so basically I initialize some variable called LastValue, so to record my last node's value in the in-order tree, in-order traversal. So basically, when I'm at 2, when I'm at 1, the last value is none. When I'm at 2, the last value is 1. When I'm at 3, the last value is 2. When I'm at 4, the last value is 3. When I'm at 5, the last value is 4. So all I need to do is, if the last value, so when I traverse to 5, my last value is 4, right? If my last value 4 is equal to the p-value, so when 4 is equal to 4, that means my last one is the p I want to find to, and my current one is the successor I want to output. So that's why I'm saying I initialize the last value, and at each step I assign the root value as last value. And when